I'm Ramon.
I'm Jacob. This is Lab 11 Diffraction.
Go.
Okay, using the rectangular slit, we're calculating the distance where we need to be from the slit to be able to look at the Fraunhofer refraction. Using this formula here, we solved for L, and we ended up with 7.5 kilometers to be able to see the diffraction. But because we're using a lens, we're able to focus infinity into a shorter distance, which was about 10 to 15 centimeters only.
This was our setup here. We have the laser here, and this collimates the light. This distance right here is 77 centimeters about. And to get the different diffraction regions, this is altered between about 5 and 30 centimeters, this distance right here. Here we have a picture of the single slit aperture, as you can see from this setup. Ramon will slowly move it away to get two different diffraction regions. The first one that we will see, this is the Fresnel region. This is from a close perspective of diffraction. And as he moves further and further out, we see a more solid Fresnel region, and then as it goes closer and closer, we see the inverse space of a Fourier transform to get Fraunhofer diffraction. From right here, it'll get small and small, and there we have it. That's Fraunhofer diffraction. Here are images of 4 outputs of different slit widths, 20, 40, 80, and 160 microns. And as you can see, as you increase the slit width, the width of the output, it gets smaller and smaller as the inverse relationship of a Fourier transform. What we noticed is that from going to 40 to 80 for a slit width, we increase, well, have it 40 has more of an envelope size. As you see, this is about half. But going from 250 to 500, there are more oscillations within the envelope at a higher slit distance. The triangular, circular, and square apertures in the Fresnel region look similar to the aperture. However, in the Fraunhofer region, they are more circular with some patterns if it's not the circular aperture. The experimental value was 0.04719. The value we got was 0.5203. That gave a ratio of 1.1025. And on the lower minima, the ratio was 0.04595, with the theoretical is 0.006. Here was our experimental circular aperture versus sombrero function. Over here are our second maximum, but however we couldn't get an accurate one because the camera quality was so bad. Our I naught was 0.017 and our I was 0.045, and that gave us a 2.68. However, that's grossly inaccurate because it was so small. Under airy disk, Fraunhofer refraction, and bright triangles, we found the distance that 2 points can be resolved is this value right here for Z. An example is this right here, where 19.5 kilometers is that distance.